So I apologize for the abrupt ending of the last video. I accidentally pushed complete on my recording software and there's no undo button, so I guess it had to be done. But anyway, so let's finish off example number 8 here. So in the first part of this example, we found the force that was acting on our first wire, which was right here. And now for the second part, we need to find the force acting on the second part of the wire, which is this horizontal part. So one thing that's going to be really important here is that if you look, so far we've been trying to make right triangles. But right now, we have a rectangle, but there's no information that we can really use to make a right triangle. So this is where our concepts from our first lesson, based on the 4 different types of forces, comes in handy. So, knowing that this sign here isn't moving, that means that the force that's pushing to the right is equal to the force of pushing to the left. So while we may not be able to find this force pushing to the right, we can find, using what we know about this concept here, we can use that horizontal, that force that's pushing to the left, in order to find that other force. So let's find our FT2. So just to reiterate, so the force that's pushing to the right this way is going to be equal to the force pushing to the left. And we know that's true because this sign is not moving, which means that our forces are at balance. So if we find the force that's pulling to the left from this wire, then we will know our force that's pushing to the right. So in order to find this little part here, which I labeled here as y, we are going to be working with our trig ratios. We have an angle, we have our adjacent, and we have our opposite, meaning we are working with the tan ratio. So I'm going to plug in my information here. So we have tan of 55 degrees is equal to my opposite, which is 245, over my adjacent, which I labeled as y. I'm going to write tan of 55 over 1 so I can cross multiply to solve. So we have y times tan of 55 is equal to 245. I'm going to try and get rid of this value here connected to y, so I'm going to divide by tan of 55. And make sure you do that to both sides. So if you plug that into your calculator, we should have that y is equal to 171.55. So we want to make sure we round using sig figs. So looking at this 245 value, we have 3 sig figs. So our answer also needs to have 3 sig figs, meaning our ones position right here is where we need to round. So our actual answer here is 172, and our units here are newtons as we're talking about force. So that is the value for the force of our second wire. So we can write this now as a sentence. We have finished off this question. We found the force of each of the different wires acting on this sign to keep it in place. So the force of FT1 is 299 newtons, and the force of FT2 is 172 newtons. Okay, so now we are going to move on to Newton's third law. So Newton's third law is often stated as, when an object exerts a force on a second object, the second object exerts a force on the first that is equal magnitude but opposite direction. These forces are called an action-reaction forces. So I'm going to underline that right there. That's our important concept. Action-reaction forces. So if I wanted to simplify Newton's third law, we could say that for every action force there exists a reaction force that is equal magnitude but opposite in direction. So say if you were to have two forces, say maybe we have the force of an object A that is acting on object B, that would be equal to but opposite in direction, so we have a negative force of object B acting on object A. So in other words, for every action force, there is a negative reaction force. Okay, so this is like a really tough concept for people to kind of get their brains wrapped around. So I'm just going to flip over to, I have the Pearson physics textbook here. And so the analogy, or the example that they use is when you're swinging a baseball bat and it strikes a baseball. So when we're talking about the action-reaction forces here, so the action force is the forward force that the ball exerts on the ball. The reaction force is the backward force that the ball exerts on the bat. So during the collision, the ball accelerates forward and the bat slows down as it accelerates. So that's due to that negative force that's being acted upon that was from that baseball. So anyway, so hopefully that, I don't know, maybe that example kind of helped clear it up just a little bit, but as I said, this is a really tough concept. So we're actually, in our course, we're only going to look at identifying what the action-reaction forces are. If you want to learn more, though, on Khan Academy, if you were to look up Newton's third law, they actually have a really great video on Newton's third law, and they actually even have a little discussion about astronauts in space and how they use apply Newton's third law to help them get back to the space station if they were ever to disconnect. So it's kind of a really cool video. I would recommend definitely watching it. But the big idea out of this is that for Newton's third law, is that we just have to be able to identify the action and reaction. So let's do some examples and let's check that out. Okay. So here we're going to identify the action-reaction forces happening in the situation, and that is all that we need to do. Okay? So in example A here, we have a badminton racket is hitting a birdie. So the action that's happening here, so the action is that this badminton racket is hitting the birdie that's pushed, and it's pushing the birdie forward. So the racket hitting the birdie is that action, and it pushes it forward. So then the reaction, so that negative direction is coming from that birdie. So our reaction here is the birdie hitting the racket is pushing it back. That should be a C there. So example B here is stating that we have a boat that's being rowed. So our action here, in order to make that boat move forward, is that someone there is actually taking some oars and pushing against the water. So the rower, or the person in the boat, so they're pulling the oars backwards. The oars backwards, or pushing them forward, depending on which way they're facing. And that pushes against the water. So then your reaction is that the water pushes against the oars, which in itself helps move the boat move forward. So it's going to move down here. So for example C, so here we have a gun is being fired. So the action here is the gun, or the gases from the gunpowder explosion, pushes the bullet forward, whereas the reaction is that the bullet pushes the gun backwards, so you get a little bit of that recoil. So your action here is the gun, or more specifically those gases from the gunpowder explosion. Push the bullet forward. So as your reaction, so the bullet pushes the gun backward. Okay, but that does it for this lesson on Newton's 3 laws of motion. So if you have any questions, comments, concerns, make sure send me a message on Remind, and we can try and clear it up either through a message or I can try and answer it on Zoom. But thank you guys so much for watching, and let me know if you have any questions.